this one. This is Marley.
Hi, Marley.
Marley's going to demonstrate some different forces for us. Don't worry, Marley. The first one's really easy. It's called normal force. So we know that objects in midair fall. Why not when they're on tables? The answer is normal force. Even though the table isn't moving, it's still making a force, pushing up on Marley while gravity pushes down. It's happening to you, right now with your chairs. The tiny particles that make up your chair are all cozy together, and they don't want to move apart to let you through. Normal force happens whenever two objects are in contact with each other. Good job, Marley! And now for applied force. Stop. Applied force is when something pushes something else to make it move. In other words, you're literally applying force. Like this. Stop again, please. Yeah, right there. That's great. Now you're about to see the next type of force. You've probably heard of it before. It's called gravity. Gravity is the force that really, really huge objects like Earth or the Moon have, which pulls everything else towards them. Actually, everything has gravity, but we're so small that it makes no difference. So if I let Marley unfreeze, the Earth's gravity will make him fall. Sorry, Marley. See all those little air molecules? Well, they're what causes a little something I like to call air resistance. Air molecules float around us and let us breathe. They're tiny and so spread out that we can't see them. But when something moves through the air like Marley is, the air molecules hit him, but are so small that they don't make a huge difference. However, if an object is moving fast enough, it does make a difference. Like when you stick your arm out of the car window while it's going fast. Air molecules aren't like the chair particles. They're okay with moving apart to let things through. In Marley's case, he's dense enough that he falls pretty easily through the air, but something like a feather is really light compared to how big it is, almost as light as air. That means that it falls really slowly. It sits on top of the air and slips through a bit at a time. This is where things get really interesting for Marley. What you're about to see is spring force. That's what happens when a spring is compressed or stretched. It wants to get back to its normal shape, so it exerts a force. Let's slow things down so we can see what happens. Marley hits the spring and pushes it down, compressing it into a smaller shape. When the spring can't take being pressed any smaller, it springs back up, launching Marley into the air. Again. Okay, Marley, you can land now. The thing about forces is, when there's a force acting on an object, making it go a certain direction, the object just keeps going, getting faster and faster. But Marley didn't speed up. He slowed down. He stopped. So, why? Friction, the same stuff that makes your hands warm up when you rub them together. The same stuff cars need to move. Having no friction would be like every surface being super slippery, like having a sheet of super slick ice over everything, or banana peels everywhere. But to really get exactly what friction is, we have to zoom in a lot, all the way down to molecular level, where we can see the little particles that make up Marley and the ground. Normally, Marley looks like a smooth, round ball. He is a smooth, round ball. But even on a smooth surface like Marley's, not all those tiny little particles line up. They make little bumps and rough spots that are so small we can't see or feel them. Right now, you might be thinking, if they're that small, how on earth do they change anything? Here's how. When Marley rolls over the ground, those ridiculously tiny rough spots and bumps hit the ridiculously tiny rough spots and bumps in the ground. Every one of those collisions slows Marley down a little more. Thank goodness they do too, or Marley would never stop. Speaking of Marley, what have you got in your mouth? Oh, it's a nice string and all, Marley, but we're a bit busy right now. Look out! Well, this is actually the last kind of force, everyone. It's called tension. It's what happens to a rope or a string when it's being pulled taut. The rope doesn't move like it would if the force was gravity or applied force, because it's being pulled from both ends. But all that energy that Marley and the other ball are using has to go somewhere, so it goes into the rope. The more force from each end, the higher the tension in the rope, until the rope breaks, or one force gives up and leaves. Marley, thank you so much. You've been a big help.